Hi everyone, it's Kristen, and today I have a video for you to cover the information that's going to be on your practicum 2 when you're reviewing for this over the weekend. So let's just jump right into what is going to be covered on this practicum. Well, it's cumulative, so that means that anything that you've been tested on up to practicum 1 is fair game, and then we're going to be building off of that into the stuff we have learned since then. So a couple of new things that we've learned about arrays and iterating over arrays with iterative values like I or j or count or things like that. And those arrays have data types just like the variables that we have used. So double, int, string, char are all examples of arrays that we could have. And arrays are containers, right? And they're static containers, which means that they have some size, which is set, and that is very inflexible in C++. So we have to make sure that we're iterating until we reach that size, actually until we reach one less than that size, because if we actually iterate to that size, we would be having segmentation faults because we wouldn't have that many containers, because index values always start at 0 in C++. We've also been working on defining functions. Functions are really useful for breaking your code up into different sections so that you can do something specific in a certain area and have it be broken into a function. And functions can call functions as helper functions. Some functions might be larger, some might be smaller. But in general, we're going to have something along this line where you're going to have some value for the return statement. So each function will have some value for the data type that you will return from that function. So in this example, we're looking at a double array sum function. Array sum will return some double, and it will pass in two arguments of a double and an integer. The first one is an array, which we have to pass the brackets in order to have it be recognized as an array instead of a simple variable like a double variable called ARR. And we also need to pass the size or the length variable for accessing that ARR. Since it's static in its size, we need to know that size in order to iterate over it. Arrays are passed by reference. So this is another thing that's really important to know. When you're dealing with arrays, you want to make sure that if you pass an array and it's declared somewhere else, say in your main, and you pass it to, say, a function, the ARR that you manipulate in that function, if you change it in any way, you do some operations on it, maybe you sort it, maybe you add a value to it, you look for something inside of it and you change that value. If any of that occurs and the array is changed, it will be changed in an original location wherever it is stored. So if you went back to your main after that function finished its execution and you tried to check the contents of the array, you would notice that the contents of the array had been updated after the function call and after it was returned back to main. And we don't ever return arrays as a return value because arrays are passed by reference. So we can pass an array as an argument into a function and then do something with it. And then because of that, we've passed it by reference automatically because it's an array and not a regular variable. And so we would be able to check the contents and see what they had gotten updated to after the function call. The two types of loops that we have gone over so far are for loops and while loops. The difference that I would like you to focus on with for loops is that they are great when you know the size or the number of containers in the storage location of what you're iterating over, right? So if you're going through a string, you'll always know the size of the string if you're using the string library. And if you have an array, you have to pass that array into a function with its size, so you'll always know the size of an array as well. So for loops are great for indexing over arrays and for parsing string values. While loops, on the other hand, are perfect for when you don't know the number of things that you're going to be iterating over. And with while loops, you're going to have some terminating condition in your parentheses, which will be an argument that will be true until it is proven false. So in this particular example, this while loop is set to run until I is less than 10. And if I starts at 0, I is going to continuously increase until it reaches one value less than 10, which would be 9. The moment that I reaches 10, though, it can no longer perform its operation, and so it terminates because the while logic overall has been proven false. I is 10, so it can't run. And so we return 0 after that, after printing 10 numbers of cout statements. A good thing to note with the for loops is the 3 different parts of the loop. You have the initialization of your index variable I. So we have integer I is equal to 0. So what we're saying is that this I is localized to the scope of our loop. We will only use it in that loop to index over some container. And we're going to give it some terminating value from I less than 3. So we're saying that I starts at 0 and it always has to go to 1 less than 3, which is the size of that container. And then the last thing besides the terminating condition is the iterative value. So we're increasing I in the last step by 1 every time. So we start at 0, we go until we are 1 less than the size, and we increment by a certain number. In this example, we're increasing by 1 so that we always check every single container along the way. And the last big thing that you might be tested on this practicum is file I/O operations, file input-output operations. So when we're reading from files, we are inputting information from the files. So we'll use an IF, or an input file stream variable, which is a special type of variable that comes from the FStream library and allows us to declare a stream variable called something like ifstream file handle in this example. And we're going to use that to open a file and then parse it. The general steps that you want to follow are as follows. You want to declare some stream variable of an input file stream or an output file stream or an fstream, depending on what you're doing. And I'll go into the difference here in a sec. And then after you've declared that variable, you want to use it with a built-in function called open to open a file. And you'll open a txt file by passing in a text argument. And then you're going to start parsing that information if it is open. So you're going to check to see if it is open. You're going to go in and start parsing the information. And you're going to do some operations on the data. And then after that occurs, after you're done reading the file, the last and really important step is to make sure that you close that file stream after you open it and after you're done with all of your operations. There are multiple ways to parse a file, and you can get creative with solving that kind of problem. You could use the file stream variable a lot like a cin or a cout variable. So in this example, you can see that it says while you can use the file stream, then we want to store something similar to a cin. If we replaced file handle with cin, we would be getting pretty much the same thing. Cin string, we're grabbing something and storing it into the string, and then we cout that string once we grab it. With this example, you're only grabbing something up to a separator character. So you would not grab an entire line of information, but everything up to a separator character. If you wanted to grab the entire file, you would have to use something like a get line. And instead of a cin argument for your input location, you would be using a file stream variable. And you would have some target destination, which would be the place where you would store that information after you grabbed it. So ofstream, really briefly, works a lot like ifstream, but it works more like you are using a cout statement. That's the best way that I can describe it, is that cin is a lot like you're bringing stuff in from the file stream, so it'd be like file in, and then you could use file out to also write that file. So if we have some string information, we can just file handle out the information caret caret into a file, and it will write that information to the file for us. And if that file was not already available for us to write to, if we open a file and just give it a name, it actually creates that txt file for us and stores it in the same folder subdirectory of where our code currently resides. And we can also do this with a loop. We could put a file stream variable into a loop, and we could print the contents of variables or arrays or things like that, and then have that be written to a text file for us. So these are the general things that you could be tested on with this practicum. I'm going to go ahead and jump into some code that we went through in the review. And I'm just going to go over a couple of things. Before I get into any functions, I want to go over one thing in particular, which is I want to make sure that everyone who takes this test knows how to use a POW function. So a POW function is taking some value. The POW takes some value, which is your base value, and then comma, it's going to take the exponent value. And then that is going to be stored into some variable. That variable will keep the value from this operation. So in this example here, I have this integer value, which I've set equal to my POW function, which is coming from the fact that I'm using math.h, or you could also use cmath as well. These are doing the exact same thing, math.h and cmath. So I'm going to keep one of them in here and use that one. And then I'm going to print the value after the fact. So if I run this code, you can see that we're getting the value of 36 for multiplying 6 times itself. If we did this another time and we save the code, we would get a similar answer, but it would be the a cubic version of that base raised to a cube. So now I'm going to go ahead and start talking about file, I/O, and array implementations. So I'm using a split function, and you will more than likely have access to a split function in the back end of some questions on CodeRunner. So as long as you know how to call a split function, you will be able to use that split function. So let's think about, what does a split function take? Well, a split function takes in usually 4 arguments. We're going to take a string value for the line of information we want to break up. We want to pass a separator character for where that information is being broken. And we're also going to have a storage container of some type as the information being parsed. So this is a string container because we're parsing string information from the line. And then I'm also going to pass the size of that container for the line. And this could grow or shrink with your data. So if you have a small set of data, you could do 2 or more, and you could go up to n number of pieces of data on a line. So let's think about the data that I have coming in from my text file. If I have this txt file called students.txt, I've got a bunch of names and there's scores from, say, a test. And I want to figure out which score was the highest in this file. Then what I can do is I can parse through this information and keep track of the values and then figure out which one of those is the highest value. I'm using a split function here. I'm not going to go into the split function logic because that's something we have already covered. I'm just going to say that it works and that we could use it. Down in my main, before I call my function that's going to be my file I/O function, I've got a couple of things declared. I've got this file name, which is going to be equal to the students.txt file here that I have, and it's going to be saved in the same location in my subdirectory folders, so that this CPP file can access students.txt. Otherwise, I would have to specify the file directory here to get to that file, as well as the name of the text file. I have a score here, an integer variable called max score, which I'm using to catch whatever comes back from read file, and I'm passing the file name that I declared here on line 117 into my read file function, and then I'm going to just print out what was the best score on the exam using max score. So if we go up here to read file, we can see that it's an integer function, so it's going to return that max score. We know that the data here from the file is all max integers, or maximum integers, so we can use that. And this is the value that I'm going to return from the function. So the first thing I do is I know that I should return that, so I'm just going to declare it at the top and set it to some base value. The next thing I'm going to do is I'm going to declare an input file stream variable called infile. And this is going to be what's going to allow me to access all of my library functions from the fstream library. My string line is going to be used to parse the information. And I'm also going to keep track of all of the scores that I see. I know that there's 20 students in this txt file, so I've set up a scores of 20. And I'm going to have some iterative value for that scores array, which I'm using a k value. You could use any value. You could use a count. You could name it whatever you want to. But just know that it's a separate iterative value for the scores array. And I know that there's only 2 types of data on each line. So when I split this information, I'm going to pass a size of 2 every time and set a temp array to that size as well, so that I can store both Abigail and 77, or name and whatever value as I go through the file. So this is tailored specifically to the information that I'm given from my text file. So after I have done this, I'm going to open the file that I'm given through my passing parameter argument, and then I'm going to check immediately to see if it is open or if it has failed to open. In this particular example, I chose to use the .fail command, but if I was using infile.isOpen, we would switch the logic and we would do if infile.isOpen, we would do our file operations here, and our else would be what our if is currently set up as. So if I go into my logic here, if the input, if the file failed to open, then we will print out that it failed to open, and we will return some flag value. So -1 is telling us that if we get a -1 from this function, then it never opened the file. And lastly, before I even go on and actually parse the data, I'm going to go ahead and close the file stream before I forget to later. Going into this else block, else we have correctly opened the file and we can actually do something with it. So I'm going to use a couple of other variables here. I'm going to keep track of a temp and a temp score. So the temp score is going to be keeping track of the value that I have currently on each line. And then after that, I'm going to use that to update an array of values. So you can see here that I'm using a while loop with a get line thrown in. The get line is taking in a input value, which is in file. That's the target location the stuff is coming from. And the line variable is where it's getting stored to. So every time it's saying, while you can grab a line from the file stream, store it here into this variable. The next thing I'm going to do to handle inconsistencies in the file types, I'm going to check to see if every time I grab it, if that contains some value or not. So here I'm saying if the line does not equal an empty string, then and only then do I actually want to parse that information, because I would have split errors if I passed some information that didn't have any values in it. And otherwise, I just want to continue. So what I'm doing here is I'm saying just like the same thing as I++ or something. But since our while loop is not based around an I loop, we can just say continue, and it will continue to run through and check the next line. It just skips the line and continues the process over again. So if we do have information on the line, we're going to call our split function, and we're going to pass it the line, the delimiter character, the temp array, which is the storage location we're going to split the line into, and the size of this information here. Since I already declared a variable here, I could always use size as well. And you can do it either way you want to. The temp score becomes the converted integer. So I'm doing an STOY conversion on the temp array of size 1. So there's only 2 container locations. There's a 0 container and a 1 container in this example. So temp score becomes the 1 because that would be the second container of the information on the line. And then after we finish this particular score, right? We've grabbed this information from one line of information, and then what we're going to do is we're going to store the temp score after it's converted into some scores array at some kth index, and then increase that index so that after we add that, we will increase the index location of our container so we can add to a new index location every time. And after that, actually, that logic right there will handle all of the entire file, right? We split the information on the line. We then grab the information we want by converting it and storing it into a variable. And then after we do that, at the end of that loop for that particular line, we're going to sum up, or actually not sum up, we're going to just store one at a time into some storage location, and then just keep track of that storage location with an index value until we just run out of stuff to grab. And of course, like after I do all of this, I make sure that I've closed the file. So once I've done this, I can then go through here and I can find a max value. This is similar to a question that you've had before on some of your homeworks, where I say that max score, the value that I set at the beginning of my function, that I'm going to just statically set it to the first value at the 0 position of the scores array. So scores is keeping track of the values from the file, and scores will have had all of its values updated at this point after we finish reading from the file. So we're just going to start with max score being at the first index value that we can find in scores. And then what we're going to do is we're going to loop through the scores array using a for loop, because we know its size to be 20. And if we see a value at I in the array that is larger than the max that we have currently stored, then the max becomes that new value. So the first time I equals 0, this will be the same. Max score will equal scores of 0, so it won't get updated. But if we see anything past that, for instance, if we store 88 as the next scores of I, then 77 will be overwritten with 88, and 88 will become the new max value. The next thing I want to talk about is how do we do output file stream variables. So assume that everything works up to this point and you've gotten the information that you needed from the ifstream operations that we have created up to this point in this code. Well, we've got an array of scores which we could output to a file and store that information. So what we can do is, after we've closed the first file stream, we want to open the output file stream, which I'm calling output file, out file, and I'm going to open a new text file which I have not created yet called the score results. So when I open this, I'm actually creating score results for the first time. I then check to see if it's open here. So this is the other version of the logic here. Instead of saying .fail, we can say .isOpen. And this would tell me if it actually worked correctly. And if it does, then what we're going to do is we're going to run this code. And what we're going to do is we're going to loop through our scores array, and we're going to use the out file variable to output this information on this line to our text file every time that we have a value. So we're going to output this for 20 lines of information. So we would have a similar output into our text file, but it would just show the word score, the number, which we're going to start with from 1 to 20 instead of from 0 to 19 by just adding 1 to our iterative value that we're printing. And then we're actually going to print what is currently in the scores array that we have parsed from the original input file stream. And then, of course, after we're done with our output file operator task, once we're finished writing to a file, we want to make sure that we close that file. And especially with ofstream, you want to make sure that you close the file, because this would allow your file to be written to by anything else in your code. So to make sure that you don't have junk values, always, always, always close your file streams. And then once we do all of this, we should still have a max score from our first for loop here. So we can just return that at the bottom and print it down on line 118. So if I was to save this and I go over here to run the code now, We know that the ofstream opened successfully because we got it to print here because it opened the file correctly. And then what we did was we also printed that the best score in the exam was 99. You can see that if we look in our student.txt file, the largest value out of all the values is, of course, 99, and it's actually the last value out of all the values, so it had to keep updating along the way until it found that 99. And if I was to check my directory, I now have this score results.txt that was not there before, and we can see that it's over here outputting exactly what we wanted it to, which is the I value +1, and then the score on that particular line. And if we compare that to the other file, we can see that we got exactly what we wanted on every line as we went through the text file. So I hope that this was informative and it helped you with getting ready for your practicum. Just remember that we're going to be dealing with everything up to file I/O, and just make sure that when you're doing these operations that you can do file I/O on any container size and that it can work on any type of data. You want to make sure that you're tailoring it for general things. And I always tailor my file I/O to match the information coming from the text file. So if you get an example that you can look at for what is the way that the text file is structured, you can use that to build your code. Thanks, guys, and I'll see y'all next time.